Determine the length of the intercept on the straight line x cosine alpha plus y sine alpha equals to p by the circle x squared plus y squared equals to a squared. Let us begin. So here we have a circle. So this circle is centered at the origin 0, 0. Because we know that any circle whose equation is given by x squared plus y squared equals to radius squared, it will be centered at the origin. We have a straight line. Let's say this straight line is intersecting the circle at 2 points, point A and point B. So here the equation of the straight line is given to us. That's x cosine alpha plus y sine alpha equals to p. Our goal will be to determine the length of the intercept AB. So how shall we find out the length of the intercept? There's a standard formula that we will use. So let's quickly recall the formula for finding out the length of an intercept. The formula is given by 2 times the square root of the square of the radius minus c squared divided by 1 plus m squared. So here c represents the y-intercept of the line and m will be the slope of that line. So that means our first task will be to find out the slope and the y-intercept of the line, whose equation is given to us. So let's start with the equation of the line. We have x cosine alpha plus y times sine alpha equals to p. So what we'll do, we'll try to rewrite the equation in the slope-intercept form, which is given by y equals to mx plus c. And if we can write it in this particular format, then we can easily obtain the slope and the y-intercept. So that means we have y times sine alpha equals to negative x cosine alpha plus p. Let's divide each terms with sine alpha. So we'll get y equals to negative x times cosine alpha over sine alpha plus p over sine alpha. So that means we have y equals to negative x. The ratio cosine over sine, that is nothing but the cotangent function. We have cotangent of alpha plus p. So we know the reciprocal of the sine function is the cosecant function. So we get p times cosecant alpha. We're going to label this as equation number 1. So from here, if we compare with y equals to mx plus c, so we have the slope given by negative cotangent of alpha, and the y-intercept c, that's going to be p times cosecant alpha. And we have the equation of the circle x squared plus y squared equals to a squared, which implies that the radius of this circle r, that's going to be a. Okay, now let's do one thing. Let's use the value obtained. This is 3, let this be 2. The slope, the y-intercept, as well as the radius, and substitute into the length of the intercept. So we are going to get 2 times the square root of a squared minus, so c squared will be p squared cosecant squared alpha divided by 1 plus the square of the slope. So negative cotangent alpha whole squared will be cotangent squared alpha. Fine. Now here, we know that 1 plus cotangent squared alpha, there is a standard identity. 1 plus cotangent squared alpha is nothing but the square of the cosecant function. Means we have cosecant squared alpha, which means that the numerator and the denominator will get factored out. And that leaves us with 2 times the square root of a squared minus p squared. And this is going to be the length of the intercept on the straight line, whose equation is given to it by the circle x squared plus y squared equals to a squared.